Hello everybody, and today I am going to make the editorial video of Codeforces Global Round 40. So let's start with A problem, Phenoxy and gold. The observation is that we can print the array as it is. Just we need to, as all elements are distinct, we need to check that if for some I, if we cannot take this element, then we can take the next element, and then this element, as the elements are not zero, the sum will change and will increase, and next all elements are distinct, so it will not be x. And if it's the last element, that means the sum of the whole array is x, then we can not arrange it, and the answer is no. So here's the code. So, yeah, so if sum of whole array is x, then we print no. Else if we try to print it as it is, and if we take some, and after taking some x, something it would be, and if we take the current element and it is equal to x, then we need to take the next element, then the current element, and we need to add the sum of both. And if it's not x, then we print the element. Else we print first the next element, then the current element. Let's go to problem B. So yeah, so what we have to see is that a square can be made only by 2 or 4 isosceles triangles as given here. This and this is isosceles triangle, as this is 90°, this is 45, 45, 90, 45, 45, 90, as it's isosceles, both angles are 45, so it's making a square. And so only with 2 isosceles and 4 isosceles triangles we can make a square, and we can have 4 like the squares, 4 squares of isosceles triangle. We can keep it like this arrangement to make a big square. Same goes for 9, 16, 36 and 49, and so it should be a perfect square. It should be a perfect square if we take each element, each square to be of 2 isosceles triangles, or each square to be of 4 isosceles triangles. Then it should be, it some any of the case, it should be a perfect square. Else if it's not a perfect square, then it's not possible to make it. And you cannot take some with 2 isosceles squares and some with 4 isosceles squares. So because the side will be different, this side will be different, this side will be different. This is a big square as it's made by 4 isosceles triangles. This is a small square. So that's the thing. So let's go to the code. Yeah, so first of all it's odd, then it's not usable 2 and both 4, so we cannot do. Else A is nothing but taking of 2 isosceles square, so we have half, which is these many squares, and we are just checking if it's a perfect square. Else if it's not divisible by 4, then it's no. This is the number of squares, and we check if it's perfect square, then yes, else no. Let's go to the next problem, C problem. Yeah, so each height is less than equals to x. So this is the thing that for any min and max, okay, I add suppose x. So suppose difference is 0, then difference becomes x. If difference is 1, then of course I will add it to the minimum element, or the element which is less than max. So it will be x minus 1, so it will never exceed x. So our answer is always possible. Now what we'll do is, we'll take the minimum element and we'll add the maximum element which is remaining. That is, we can sort it, and then, or we can sort it and then we can add we can first make m, this is first, second, third, fourth, and which is the minimum, we can add this element to it. Now the next element minimum we can add this, next minimum we can add this. Never the sum, the difference will exceed max, as I showed you here. The difference, if it's 0 difference, still it will max to max go to x, and then I will go to the minimum one. So I can use here set data structure to do so. So let's go to the code. Yeah, so set of pairs, that is the key value, or 1 to m blocks are there. So which block one, and what is the value or the sum of the blocks in this block. So, and this is the array, this is the I, because we want to sort the array, so we need the position, as we have to print the block according to the position. So answer is of size n, this sort, and the position of this element is the block, that is first block, second block, up till m block, and I insert with the value or the sum of the current block and the key of the block, and then the pair is the first element, as that's the smallest element, the smallest sum block, and then we erase that, we don't want this, and answer of the current element will be the key value of the block, and then we add the value, some value, as we are keeping the block in the current block, so we add it, and then we insert p again. So now the value is added, that is this element is considered in the first block or the least sum block, and then we print yes and we print answer. That's all. Let's go to problem D. Yeah, so first of all we have to do some observation. The observation is that if there are some left and there are some right, so if there is some same element, this is same SNS, then we pick these two, that's an optimal. Okay, so now remaining, I know that there will be remaining, this will take 0 steps or $0, so the remaining is all different, these are different, these are different. Okay, so now there is a possibility that L is greater than that, though the difference will be even, because this n is even, the difference will be even. N is even, so there are two ways, L is odd and R is odd, so it can odd minus odd is even, and if L is even and R is even, then even minus even is also even. So difference is even, then we have to convert difference upon 2L to R, or vice versa if R is greater than L. So which we have to convert the number. So if suppose L is greater, then we have two same elements over here, then we put this to this using $1, as these all are same, this and this are same, so it goes on the right, and now this and this can be made pair in just $1. And if I send to, if this belongs only, this is the only single in this L, and we put it here, then one more dollar will be used for making it equal to someone. Okay, so this is the optimal way. If they are two same, then we put. Same goes for right, if right is greater, and if both are equal, then we don't have to shift. And the answer ending is that the number of L's or the number of R's remaining, because we have to change either L either R socks to be equal color of the socks. Okay, so I will go to the code now. Yeah, it's a little big code. So first of all, L or R can be 0, so we can't take an array, so we have to take vector every time. So we take array first, and then we take vector, and then we divide L as A and R as B. Then we sort it, because we want I'm using two pointer method to find the number of same in L and R, or find the same pairs in L and R. So I have to sort to use two pointer method. Here visited, because we have to check if we have already taken a pair with it, then we don't need to take another pair with it. So for that, and J is the second pointer, I is for L and J is for R. And while B of position J is less than A of position I, that means no element is matching with I am J plus plus. And if J is if the pointer has finished the whole array, then we break. And if A of position, if both are same, then we visit both, that is both are pair now, we don't need any pair. And J plus plus, as I plus plus is happening, J plus plus for the pointer next element. Now difference, as I told, R minus L, and difference upon equals to 2, because we want half balance. And answer is different because we need different dollars, that is at least different dollars. Now this L is greater than R and R is greater than L is the same, just variable changes are done, other all is same. As I told you, it is can be any. So P is the previous and position is the previous position, and count is 0. Count is the number of shifts we have done till now. And while L is less than N, because L is greater, and count is less than difference. If visited, that means we don't need to do anything, we continue this as a pair. As if previous is not being taken, then previous is A of position I and pos is I. And else previous is taken, then we check if it's same, then count plus plus, pos becomes -1, previous becomes -1, and these both are visited because both have been taken. Else I make this previous as it's sorted. And for each, if it's not visited, then I to change the color. And if I have not shifted the elements, then I changed twice, so I will remove difference minus count and save for answer. Else here, if both are same, then I just have to count the number of not selected ones. Okay, so thanks for watching my video. Don't forget to like, subscribe and click the bell icon.